So last we come to section 5.2. In this session, we're going to talk about linear inequalities. And we have looked at the linear equation in two variables, right? Such as y equal to 2x plus 1. The solutions are all the point on the line. Solution are all the point on the line, right? And the solution, so now we're going to talk about solution to linear inequalities, which is all the points shaded on one side of the line, and it may also include the line. May, okay, maybe I use other color. So this one may include the line, and it depending on the side, right? So if it include the equal like this, you will say included the line. Okay. Okay, so let's start. Do example 5.3. Okay. We're gonna grab the solutions y less than 2x plus 1. So we will have to do we will have to grab the line, grab the line y equal to 2x plus 1 as a dashed line. So, and you see over here, I did have it as a dashed line here, right? How to grab y equal to 2x plus 1? You can, just using t tables with 2 points is enough for you guys, right? So you can choose like 0, y equal to 2x plus 1, right? So 0 gonna be 1, right? And then at the point you can choose a, I don't know, maybe 1, and then that's gonna be 3, right? So you will have 2 points. One is this guy, another is this guy, and then you draw the dashed line, go through this point, and this line is like a fence for us to know there is an area that we will have to shade it later, not shade it later on one side of the line. It could be this side or it could be this side. Who knows? We have to check that, right? So now how to check that? Now we're gonna maybe I'm gonna say this is step 1, right? Step 1. Okay, so we call step 1 is grab the line y equal to 2x plus 1 as a dashed line, since I don't have I don't include these lines as I have strictly less than y strictly less than 2x plus 1, right? So I'm gonna come to step 2, say step 2, and I say step 2 is choose a point. I'm gonna say test point, not on the line. y equal to 2x plus 1. Okay. So you may have to think about which one you choose. I would suggest I choose the easiest point, which is 0, 0 right now. Because you see 0, 0 is not on the line, right? And it is easiest point. Okay. You can choose another one, such as like 1, 0, that's fine. Or anything else, whatever you like. But I usually choose the easiest one. Keep in mind that it must not on the line. If you choose like 0, 1, it is on the line, you cannot do that. Okay. So choose a test point not on the line, and then put the value into the inequality to check if it satisfies. Okay. So let's choose easiest point 0, 0, and plug in the inequality. Okay, so we have y less than 2x plus 1, right? So let's check that. We have zeros as y values less than 2 times 0 plus 1. Is that true? Let's simplify it. 0 less than 1. Oh, this is true. True statement. So since it's true statement, then that means then therefore all the area therefore we will shade the area include the origin 0, 0. We say the area on the side of the line y equal to x plus 1 includes the origin. Okay, that makes sense, right? So what I'm gonna shade is all the area that includes the point 0, 0 here, right? Let me use as a color 0, 0 was here, right? So I need to shade all of this area. Yeah. So the area that I have shaded will be the solution. Okay. So I will say the area. I'm gonna say all the point in the shaded area will be the solution of the inequality. Okay. And I mean, I want to show you if I use decimal to grab the solution here. So y less than 2x plus 1. Right? And you see that is have a dashed line y equal to 2x plus 1 is go to 0, 1 and then near 0, 5 here, right? And you have I have shade on the right side of it, right? So that's the way you decimals. Okay, what about example 5.4? We're gonna do the same, but include, right? So I'm gonna say step 1, grab the line y equal to 1/2 time with x and minus 2, right? So for this case, since we include the equal here, like less than or equal to. So we will have to, we're not gonna do a dashed line, we're gonna say solid line, right? A solid line that maybe I'm not gonna type this one. I'm gonna write, say 1/2 x minus 2, right? So for this one, you can also do by the t tables. Okay, let's choose x here, y equal to 1/2 x minus 2, right? So let's choose zeros. I'm gonna have -2, right? What else? I have maybe I choose 2. I'm gonna have 1 minus 2 gonna be -1. So let's coordinate it 0, -2, 0, -2, 1 point, 2 and -1, 2, -1, another point here. So we will have a line go through the 2 point, right? This line, okay. And I will, and this is solid line, okay? We'll try to draw it now. Okay. All right. Yeah, so as you see now, I have a solid line, solid line, solid line, y equal to a half of x minus 2, right? And we just need to determine which side will be the solution, right? We need to share it, right? So we choose again. We choose we do step 2. Say step 2. Choose the test point. I'm gonna choose test point 0, 0. Okay, okay, and plug in the inequality. Right. So what do I have? So I have 1. Yeah, I'm gonna write right now. So we're gonna do different color. This one better. So what have y less than or equal to 1/2 x minus 2, right? So 0 less than or equal to 1/2 times 0 minus 2, right? 0 less than or equal to -2. Oh, what happened? Right. So this is a testing point, and in 0, is that 0 less than -2? No, false statement. Since it's false statement, you will say, therefore, we will say the area on the side of the line that that doesn't include the origin origin 0, 0 in shading. Okay, so that's will be it, and on the point on the shade area will be solution of the inequality. Right? So what is the area associated? It should be this area over here, right? The one does not include the origin. Okay. All right. So that will be it. Okay. So I would like to let you to go ahead and practice with the next one in about 2 minutes. Right. We do the same things, and then check with my answer. Okay. Okay, so go ahead and check your solution here. And you see that I have step 1, graph solid line here, since it was include equal here, right? And I will choose a test point that not on the line is 0, 0, easiest one, and then plug into the inequalities, and I see that 0 y 0 greater than or equal to -1 with a true statement. So I will say I shade the area on the side of the line that includes origin 0, 0, and this will be the solution, right? Okay, so in chapter 4, we practice looking a solution for a system of linear equation, right? So that is finding the point that work in all the equation. So now in chapter 5, we're looking for the set of the point that satisfy all the inequalities. Okay, so we have system of linear down here. System of linear inequalities down here. Okay, so we will do similarly with the one above. Let me show you how this will help us for this. So we have y less than or equal to x plus 2, right? So this is the first area, and I have the second one, say y greater than or equal to -x plus 1. And then you see that I have another shaded area, And these two areas will have like a overlap shadings. All right, overlap shading area will be the solution of the system. Okay, so let's come back and see how we do this one, right? So we need to do step one. Grab solid line. Because they both includes equal here, right? So grab solid line y equal to x plus 2 and y equal to minus x plus 1. Okay, you will do the same way as before with t tables. So you may use x and y. You have you may do this as a sidewalk, that's fine. You put 0 here, you have say y equal to x plus 2 here, right? So this is 2, this is going to be 1, and then 3 maybe, and the other one will be y equal to minus x plus 1. So I have 0 and 1, and then the second point will be I'm going to choose another one, which let's say 3 and then negative 2. So so for the first one, I have 0, 2, 0, 2, this guy. I have 1, 3, 1, 3, this guy, right? And I draw the line, go through this 2 point. Okay. We'll need to draw the line through the 2 point. I draw the red line here. Okay. Done with one line. I will go ahead and do the second one, which is 0, 1, 0 and 1. Not this one, sorry. This is and then 3, negative 2, 3, negative 2. Okay, so we'll use other color maybe. We'll also use other color. All right. So we have 2 lines. One is the blue and one is the red, right? So I will say blue one is this guy. The red one is this guy. Okay. So that's we done step 1. We're gonna try to do step 2 is test. 0, 0, because 0 is not on both of them, right? So on H inequality. Okay, so let's test for the first one. Let's call this E1. It is the 2, right? So we have y, maybe I write better. Say y less than or equal to x but 2, right? So 0 less than or equal to 0 but 2. 0 less than or equal to 2. This is true. All right, so we will need to shade the area on the side of this. Let me copy. Let me actually copy this something here. Shade the area. Shade the area on the side of y at the line y equal to x plus 2, right? That includes the origin. That includes the origin. It is not the solution yet, okay? Yeah. So we say that x plus 2 is the red one, so we need to include the 0, 0. Right? All right. Okay, so that is the first one. What about the second one? I'm gonna separate it. Say y greater than or equal to minus x plus 1, right? So 0 greater than or equal to 0 minus 0 plus 1. 0 greater than or equal to 1, false. Right? So if it's 4, I will shade the area on the side of the line that doesn't include origin on the line y equal to negative x plus 1. Yeah. So let's shade it. Okay, so where it is. So as you see, this is a blue one, right? I want to shade the area, not include the origin. So I should go up over here, shade the area. Okay. So as you see now, we will have the overlap. Say overlap area. Overlap shading area is the solution of the system. Use this. Right. Okay, so that will be the answer for 5.5. Yeah. Now I would like to go ahead and let you work on 5.3. Okay. And yeah, we can just go quick on that together if you want. So we start with graphing two lines, right? Say x y equal to -2x plus 3, right? And then the other one will be, maybe I use the other color, blue one. Y x. Okay, so one of them will be the dash line, since it's not include equal. Another one is solid, right? So yeah, I will do this just solid. This guy is solid. Ooh. Which one is red? Okay. So I will have 0, -1. I will have 1 0. 1 0, right? And this one will be 0 3. Actually use the other color. And then I have 1 and 1. So 0 3, 0 3 is 1, 1 1, another one, right? And then draw the line, go through this 2 point. You do all this. Better, right? So draw the line, go through this. Uh-oh. Good. Let's see. Not really good. Let's redo it to make sure. One more time. One more time. This kind of really hard for me. It's kind of like trying to make it straight, but it's really hard to make it straight. Okay, so that's be acceptable for now. Second one gonna be 0 and -1. Use other color. 0 -1, right? 0 -1 will be this guy. 1 0. So 1 0 would be this guy. Draw the line, go through this. Okay, now we can go ahead and draw. This side is okay to me. All right. Okay, so we're done. Wait a second. We need to have a dash line. Is that? Oh, nice. I made a mistake, right? Okay, but I figured out that it should be this. Okay, so time to clean up things. All right. So let me. Yeah, that is good, right? And we need to know the area, right? Okay, maybe test a point, say 0, 0 again, because it's not on both of them. So let's test for y less than negative 2x plus 3 have 0 less than 0 plus 3 with 0 less than 3. Is that true? Right, true. And then the other one gonna be y greater than or equal to x minus 1. 0 greater than or equal to negative 1. Is that true? True. So they both true. We need to shade the area include 0 for both of them. Okay, so for the blue one, go, go. It's like you're painting the house, right? Okay, next. Okay, I'm gonna use this one. Next one will be includes the 0, 0, right? So the red for the red. So we mostly consider about the overlap shading area, right? Overlap shading area will use the solution. Okay, so so let me see. Here, copy this word. Overlap shading area will be a solution of the system. So this guy. Yeah. I have to move this a little bit. Okay, nice. Okay, so that's gonna be it for that's what I'm. Let's move to an application for this. A company produce a basic premium version of its product. The basic version requires 20 minutes of assembly and 50 minutes of paintings. The premium version requires 30 minutes of assembly and 30 minutes of paintings. So, so premium version require 30 minutes of 30 minutes of assembly. Maybe I use other color for the premium things. This one. 10 minutes for printing. Okay. Is the basics is the basic is require 20 minutes assembly and 50 minutes of printing. Premium require 30 minutes assembly and 30 minutes printing. So what else do we have? We have company has staffing for 3,900 minutes of assembly and 33 minutes of paintings each week. How many items? The question in here is, how many items can the company produce within the limit of their staffing? So we need, since they asking for how many items, we need to go ahead and state X is number of, right? Item, what item do we have? Basics version, right? Basics version or basic product. Basic items or basic product, that's fine. And Y will be the number of premium products. So according to the information above, we have assembly, say assembly for assembly, we have up to 3,900 minutes, which means you can work less than or equal to it. You cannot go over it. Okay, so so assembly for the so assembly will be have to be, maybe I have to write instead of type for this case. Okay, so let's write. So we have for the basic is 20 times which number of basic is X, and then adding with 30 minutes time which the number of premium is Y, and less than or equal to 3,900. Right. So that is the first inequalities. What about the second one? I would say painting, right? So painting, say I have up to 33 minutes. For the basics, I have 20 minutes. No, 15 actually, sorry. 20 minutes. I'm gonna use other color maybe. We have this one. 15 minutes of X plus how many minutes for the premium? 30 minutes for Y, and then less than or equal to 3,300 only. Okay, so we have two inequality in this case, and we need to make two lines, right? Both of them are solid, and then find the overlap shading area. So we're gonna do solid line for this guy, solid line for this guy, right? Because it includes. Okay, so how to how to graph for the line 20x. Let's say graph solid line 20x plus 30y equal to 3900. How to do that? You can also do by t table also, and 15x plus 30y equal to 3300. Okay, let me show you. Yeah, so let me show you. See, here's x, here's a y. For, let's say for the first one here, okay, it's black. So we have, let's put down x is zeros. So what happened with y? You may have to do a sidewalk, right? Have, when you plug 0 into there, we have like, maybe I put that aside here. 20 times 0 plus 30y equal to 39. I need more space, sorry. Come on. So since 0 times 0x here, 20 times 0 here plus 30y equal to 3900. You can right away say y equal to 3900 divided by 30, right? What is that equal to? Use the calculators to make sure that. So 3900 divided by 30, 130. So that's 130. Okay. We do the same thing to find the x intercept by substitute y equals 0. Right. So we have like 20x plus 30 times 0 equal 3900. So we have x will be 3900 divided by 20, right? And you will have x equal to what? Use calculator, 3900 divided by 20, 195. So that is for the first line. You can go ahead and grab it. So 0, 130, 0 and 130, say this guy. And 195, 0, 195. See, here's a 190, 195 is over here. And you can go ahead and grab it. So okay, that's the first one. I'm going to use the second one is a red line. Say x here, y here, 0. What is the y value? When x equals 0, you can put out as 30y equal to 3300, right? So y will be equal to 3300 divided by 30. What is that equal to? 3300 divided by 30, 110. So put 110 here. And then y equals 0, you will have 20x, no, 15x, sorry. 15x equal to 3300. Then x will be 3300 divided by 15. So x will be equal to 220. So put 220 here. Okay, so 0, 110, 1 point. And then 220, 0 with this guy. Draw the line. Okay. They both solid. So I can just draw it. Done. All right, so we have we did have the graph over here, and keep in mind that we have no negative values. So that means we don't include the negative in the left and in the right? So we also mean that we have x and y must greater than or equal to 0. So we need to find the shading area as before, right? So let's test 0, 0 and see, right? Say test 0, 0 on H inequality. So we have, let's write down, say 20 times 0 plus, no, I'm using this as a black one. So let's use a black one. 20 times 0 plus 30 times 0 equal to 30, less than or equal to, less than or equal to 3900. Is that true? 0, 3900. Okay, that's true. Right, so then that means we will need to shade areas over here under the black line, right? Under the black line. Okay. Then we check with the red line. Separate this. Separate this. We have 15 0 plus 30, 0 less than equal to 3300. And it's also true. Okay. So that means you will have to shade the area under the red line. Okay, so we have the overlap shaded one will be the solution. Okay. Right now I saw that it's look like a purple, right? I will say I will say overlap shaded area. Right? Yes, what I said before. Shading area, shade. Overlap shading area is I'm gonna say shows on the possible combination of basics, premium, that's that that satisfy, yes, satisfy the staffing requirement. Okay. All right. So this will be blue one. Okay. This will be it. Yeah. I would like to go ahead and let you try exercise 5.4. A cabinet show makes two types of cabinets. One type of kitchen and one type of the bathroom. Okay, so I have one type for bathroom and one type for kitchen. So manufacture of cabinets consists two steps. So making the frame and drawers. And then step 2 is assembling and finishing the units. So as you see below here, I have labor requirement as follow. Oh, actually, I don't even need these. I think this is more important here. So, what's the question? Each week, the shop has 480 hours, 40 hours of labor available for manufacturing, and 600 labor hour available for assembling and finishing. Okay, so this should be the one. Winners, right? Okay, so we're gonna show the graphically all the possible combination of kitchens and bathroom cabinet that could be produced. Okay, so we want to have kitchen and bedroom cabinets. So maybe kitchen here and bedroom cabinets here. So bedroom and kitchen. Okay. So I would suggest just label X as a numbers of kitchen cabinet. And then Y is the number of bathroom cabinet. All right. Then we're gonna need to set up the inequalities system, right? So maybe the first one will be the frame, and the second one will be assembly. Frame and drawer. Frame and drawer will be maybe I need to more space. Okay. So for frame will be 3x plus 4y. And we have only 480 hours available for that. Right. For assembly, you have I use other color. You will have 5x plus 3y. Less than or equal to 600. Okay. And you have to do exactly the same as above I do, right? Okay, so try maybe pause my videos and try it in 5 minutes, right? And handle that, right? Okay, for the red one, if I choose equal 0, I do a side out here. I'm gonna have 4y equal to 480, right? And I make y equal to 480 divided by 4. And then I have y equal to, what is that? Y equal to 120. 120. So this is 120. And in the case that's when I have y equals 0, I will have 3x equal to 480. And then, so then I have x will be 480 divided by 3. We're going to be 160. Right. So put 160 here. So this is all side work. Well, yeah, but you can also do that. So, for the black one, I put x0. I'm gonna have what? Separate this. Have 3y equal to 600. Then I have y will be equal to 200. Right. And for y equals 0, what happened with x? We have 5x with 600. Then x equal to 120. Right? 120. Yeah. So they both will be solid line since they both include the equal. So you can go ahead and coordinate those. 0, 120 first. No, we do black first. 0, 200 first. Yeah. 120 and 0. This guy. Okay. All right, that is for the first one. Use the other color to draw the red one. 0, 120, 160, 0. So draw the line. Okay. So we're done with this. Okay, so after that, you can check, right? Check with the first one will be 0, 0 less than equal to 480. This is good, right? What about the second one? 0 plus 0 less than equal to 600. This is also good. So you will end up with the overlap shading area will be this guy. Okay, you can try to shade that and you will see it. Okay. So I'm gonna say I'm gonna say down here that the overlap shading area is I'm gonna say black. No, just gonna. Okay, maybe I'm gonna shade it for you guys to make it easy. This is first one. Not include the negative, okay? Not include the negative, so I'm gonna have to. All right. And the next one will be a here. Purple. Again, it's purple. Okay. Our shading area is purple. Um, is what I gonna say is the maybe you just say shows all possible um possible combination kitchen and bathroom cabinet. That could be good for you. That's satisfied. That's satisfied for. That's satisfied for the requirement. For labor requirement. Labor requirement. Okay. So that's gonna be it. I use this. All right. So yeah, I think that's it for 5.2. And we'll see you in 5.3 later. And that's gonna be the last one, right? Okay, good.